So good morning. Today I'm going to explain about waves in IP syllabus. So the waves which carries 8 marks question, in which there are 4 questions. One is open organ pipe, closed organ pipe, and Doppler effect, 2 questions. Like that there are 4 questions. Each question, any question carries 8 marks. Only one question will be given in the examination, public IP examination. Today I am going to explain you about open organ pipe. Before that, let us explain what is a wave and how waves are formed, what are the different types of waves, and how stationary wave is formed. Wave is a disturbance created in the medium. Wave is a disturbance created in the medium. Of course, waves are different types. There are mainly in mechanical waves, there are 2 different types of mechanical waves in the sense medium is necessary for mechanical waves, and electromagnetic waves, medium is not necessary for electromagnetic waves. For example for electromagnetic waves is light waves. For that, medium is not necessary. Example for mechanical waves are sound waves and waves which are formed when a stone is put on the water, still water, then circular pattern waves will be formed. That are those waves are called also mechanical waves. So now let us suppose that a medium is disturbed. For example, if we put a stone on the still water, say this is the source, that is point of source. Here we put the stone on the still water, and this is the medium, water, and a wave will be formed like this. So here one upward portion and another downward portion. This upward portion of the wave is called the crest. Downward portion of the wave is called the trough. That is, crests and troughs are formed. This is called the amplitude of the wave. This we call as amplitude of the wave. And distance between any 2 consecutive crests or any 2 consecutive troughs is called the wavelength. It is represented by lambda. Wavelength is represented by lambda. Distance between any 2 consecutive crests or any 2 consecutive troughs is called wavelength, and it is represented by lambda. For example, if you want to find the distance between consecutive crests and a trough, then this becomes lambda by 2, half of the wavelength. Now, how stationary waves are formed? 2 waves which are traveling in the opposite direction over the same path with same amplitude and frequency are called stationary waves. For example, let us take a rope, and this rope is held by our hand at one end, other end is tied to the wall, and a small jerk is given, then a wave will be formed like this. This wave we call as progressive wave. Whenever this progressive wave reaches the wall, and a wave that reflects back, as shown in the figure, with same amplitude and frequency. Now here loops are formed. At one place the vibration of the particle is almost 0. This we call as a node. And at another place the vibration of the particle is maximum. This we call as antinode. Distance between a node and next node is half of the wavelength. Similarly, distance between a node and next antinode is lambda by 4. So distance between a node and the next node is half of the wavelength, lambda by 2, and distance between a node and the next antinode is lambda by 4. So like that, lambda by 2 is the half of the wavelength, lambda by 4 is the quarter of the wavelength. How to find the velocity of the wave? V is equal to, generally formula for velocity is displacement by time. Here displacement is lambda, time is t. That is V is equal to, this can be written as lambda into 1 by t, but reciprocal of time is a frequency, say this is n, so V is equal to n lambda. This is the formula, important formula, while we are explaining the closed argon pipe or open argon pipe, this formula we use. Now let us explain the frequencies of the wave. It is traveling in a argon pipe, open argon pipe. Let us suppose that this is an open argon pipe. If both sides of the pipe is open, then we call this as a open argon pipe. In open argon pipe, say this is the, let us suppose that this is the open argon pipe. That is, both sides of the pipe are open. In open argon pipe, there are two antinodes and one node. Two antinodes and one node. Distance between a antinode and node is lambda by 4. This is lambda by and this is also lambda by 4. So total length is lambda by 4 plus lambda by 4 is lambda by 2. Now I am going to explain you about how to find the frequency of the first fundamental frequency. That is first harmonic. Okay, fundamental frequency. What is harmonic? The frequencies of integral multiple of fundamental frequency is called a harmonic. Here, distance between antinode and node is lambda by 4 and node and antinode is again lambda by 4. Total length is lambda by 2. This formula we use, n lambda. So here, at antinode, the vibration of the particles is maximum. At node, the vibration of the particles is minimum. Let us suppose that this is the progressive wave and this is the reflected wave. These two waves are traveling through a pipe, open argon pipe, and at both open ends, free to vibrate. Particles are free to vibrate, therefore antinodes are formed. So at the middle part of this, node is formed. At node, the particles of the vibration is minimum. Distance between, this is the total length. Total length of the air column is equal to lambda by 2, or lambda is equal to 2L. We know the formula for V is equal to n lambda. So here n is equal to, what is n from this? N is equal to, or let us suppose that this is n1. n1 is equal to V by lambda. That is, V by lambda is 2L. So n1 is equal to V by 2L. Fundamental frequency. That is first overtone. n1 is equal to V by 2L. Say this is equation 1. Now let us take let us suppose that this is the progressive wave and this is the reflected wave. Here in this, how many nodes and how many antinodes are formed? Here, 2 nodes and 3 antinodes. 1, 2, 3. Here, 1 node and 2 antinodes are forming. Here, 1 node and 2 antinodes. Here, 2 nodes and 3 antinodes. 1, 2, 3 antinodes are forming. So distance between a node and a node is lambda by 2. lambda by 2. Lambda by 2. Distance between a node and antinode is lambda by 4. Here distance between antinode and node is also lambda by 4. Lambda by 4 plus lambda by 2 plus lambda by 4. Lambda by 4 plus lambda by 2 plus lambda by 4. 4 is the LCM. Lambda plus 2 lambda plus lambda. This is equal to 4 lambda by 4. This is equal to lambda. So, here for second overtone, once again V is equal to, let us substitute this formula, V is equal to N2 lambda. Total length is L. So, L is equal to lambda, or lambda can be written as 2L by L, 2 to cancel, once again we get L. Therefore, here N2 is equal to V by lambda, that is equal to V by lambda is 2L by 2, that goes to the numerator. So, once again V by 2L, we know the V by 2L value, that is N1, 2N1. So, N2 is equal to 2N1. Say this is equation 2. Next, let us take the pipe for third harmonic, third overtone. For this, we have to take the diagram like this. If you observe here, then here there are 3 nodes, 1, 2, 3 nodes. 3 nodes and 1, 2, 3, 4. 4 antinodes are there. So, all lambda by 2, lambda by 2, lambda by 4, lambda by 4. This is the total length of the air column. L is equal to, if you add all these, then we get lambda by 2 plus lambda by 2 is lambda. Lambda by 4 plus lambda by 4 is lambda by 2. That is 3 lambda by 2. 2 lambda plus lambda, 3 lambda by 2. That is the total length, or from this lambda is equal to 2L by 3. Now, for third overtone, we get V is equal to N3 lambda. Therefore, N3 is equal to V by lambda. Here, what is lambda? Lambda is equal to 2L by 3. Or N3 is equal to 3 into V by 2L. Once again, what is V by 2L? N1. That is 3N1. Say this is equation 3. From 1, 2 and 3, what we get? We get N1 is to N2 is to N3 is to etc. is equal to, what is N1? N1 is V by 2L. N1, let us write as it is to, what is N2? 2N1. What is N3? 3N1, etc. N4 is 4N1, like that. In all these, N1 is common factor. Therefore, N1 is to N2 is to N3 is etc. is equal to 1 is to 2 is to 3. That is integral, these are all integers, positive integer, integral multiple of fundamental frequency. Okay. The frequencies of all frequencies are integral multiples of fundamental frequency. N1 is to N2 is to N3 is equal to 1 is to 2 is to 3, etc. Okay. Did you understand this? So, first we have to take the first diagram in which there is one node and two antinodes. One node and two antinodes. Therefore, this is lambda by 4, lambda by 4. Lambda by 4, lambda by 4 is equal to lambda by 2. So, here lambda by L is equal, total length of the air column is L is equal to lambda by 2. Therefore, lambda is equal to 2L. From the formula V is equal to N lambda, N or N1 is equal to N or N1 is equal to V by lambda, but lambda is equal to 2, V by 2L. So, N1 is equal to V by 2. This is equation 1. Next, in for second harmonic or second overtone, the waves will be like this. Both ends are opened. In between there are two nodes and three antinodes. These are the nodes 1, 2, 3 antinodes. So this is lambda by 2 because the distance between the node and next node is lambda by 2. Distance between node and antinode is lambda by 4. Node and antinode is again lambda by 4. Lambda by 2 plus lambda by 4 plus lambda by 4 is lambda. Okay. Here I wrote. This is only lambda. So lambda is equal to, we can write 2L by L. 2 to cancel, once again L. Total length is equal to lambda or 2L by 2. So substitute the N2 is equal to V by lambda. Lambda is V by 2L by 2L. Okay. So 2 comes to numerator. V by 2L is N1. V by 2L is N1. Therefore N2 is equal to N1. Next, for the third case. In third case, 3 antinodes and 3 nodes and 4 antinodes. 1, 2, 3. These are the nodes. Antinodes 1, 2, 3, 4 antinodes are formed. Therefore, this is lambda by 2. This is also lambda by 2. And lambda by 2 plus lambda by 2 plus lambda by 4 plus lambda by 4 is how much? 3 lambda by 4. L is equal, total length is equal to 3 lambda by 4, or lambda is equal to 2L by 3. Lambda is equal to 2L by 3. So, okay. Now let us substitute these values, lambda value here, 2L by 3, that is 3 comes to the numerator, 3 into V. Again, once again V by 2L is N1, that is 3N1. From 1, 2 and 3 we get N1 is to N2 is to N3 is equal to N1 is to N1 is to 3N1, etc. That is 1 is to 2 is to 3. Okay, like that. So this is the first important question for 8 marks in waves.